So we're going to build this Wickerbill, and I'm going to try to go over all the major parts on how I did it. And I think it's pretty neat. It flows and fits the car really well. We even cut in the third brake light and made the third brake light mount up. But the first thing I needed to do, because the car doesn't have an engine in it, I shimmed up the back tires to where the rocker panels were pretty much level with the ground. And then I've taken my laser and I shot a laser and I leveled the car up side to side. And now what I've done is I've taken the laser, and it's really kind of hard to see the line, but I've shined the laser line, and that's level when the Wickerbill deck comes to the chassis, comes to the body. There isn't a spot here for the rear windshield wiper that we're going to have to do something with. And then we know where the edge of the windshield is. What I'm starting to do now is all of my factory location spots for the factory wing, I'm locating them, and I'm just starting to trace out where I want to have my brackets to support everything. And that's where I'm going to start. So now I'll come in with the narrow ones I don't have to really do anything with, but the wider ones I'm going to come in with poster board, and I'm going to make poster board patterns for the rough shape, and we'll start making those and getting them to shape. Here we are with one of our paper patterns, and I've put what I wanted to add and how much flange I felt like I needed and which side it went on. And what we'll do is we lay all of this out onto a piece of 19 gauge. I use aluminum killed drawing quality because it's nice and easy to shape. And those are what we're going to make the mounts off of. You'll see why in a little bit when I go into the further steps. But here's one that I finished. Now, everything we do in metal shaping is either shrinking, stretching, changing its form, cutting, or joining by welding, riveting, or whatever process we're using. In this case, in order to create this shape, I shrank it from here forward to create that arc. Then back here, in order to get, when I was done shrinking, it pointed up like this. So in order to get this back down level to create a flange that I need for another part, I stretched it right at this point in a V like this. And that allowed this part to relax back and drop that down. Now that'll give me a flange below the deck that I can attach the support that goes down onto it. We took our profile gauge and got the profile off the back of the car, and now we can take our part and start shrinking it in. Now this part's just going to have 2 3/4 inch flanges onto it, and it should be pretty easy to shrink in, and just going to do it nice and evenly. The key is to go slow and take your time. It's easy to over shrink. And if you can see, I'm not going all the way in on the flange. Most of the work of the shrink has to happen on the outside edge. The inside actually has very little work done, so I'm not taking the jaws and going all the way in because it's not really necessary. So it's going to be really hard to see, but I came in and shot the laser line, and I made a little mark right here, and then we know the laser line hit back there, so I made a straight line in between the two. Now you can see that this line is not parallel to that. So what I need to do is from the point of intersection here where it touches this body line, I need to stretch. So I've set up the stretcher, and then we can stretch that until this is parallel with that line there. This line is going to come down with us as we stretch. But we'll get that knocked out, and we can take another look. It doesn't take a lot, but that's just all we needed. So let's check this side. This side is fairly close, but it could probably use just a little bit more. So So now that's part's ready, and this is parallel with the other part. And just by eyeballing it, it looks very, very close. So now what we can do is this part is parallel with that part, and that gives us enough room now to where we can set some rivets into the next piece that bridges out and comes down, and there's our support to the lower edge. So the well-done hardware is holding them on, and this one here has not been stretched, and you can see how the other two are parallel, but this one is looking up. So we're going to stretch that one, get it in parallel, and then I've laid out a center line here in order to measure to make it square off the edges so I could do the two end pieces. So onto our end pieces, we've bent one flange and shrunk it into shape. Now this other side is not a straight line because the end of the hatch is wider at the bottom than it is at the top. And this line right here, what we've done is set up a center line and measured over. That way this will be square to the center line. It'll just make it look a little bit better, a little more professional. So instead of putting in the brake, now we'll have to do a tipping operation. Here we are at the bead roller. Skateboard wheel lower, tipping die upper. That's how we're going to start. With the skateboard wheel, we're just going to come down and use a pretty much max pressure. We're going to go right on that line. I don't need to do any tipping right now. I just need to follow my lines. As you can see, the skateboard wheel gives it just enough flex to where it starts to tip. Now I can switch to a hard lower, and we can complete the tip as far as we can go. And we may have to come in and do a little bit of shrinking to pull that edge up and around where it needs to be, and then we'll have to shrink to get it into shape. So now we're set up with a solid lower and my tipping upper, and we're just going to go nice and slow and only add maybe 5-10 degrees at a time. Now, because it's requiring a shape change, it may fight us a little bit, and it's definitely going to try to distort the part some. But we'll just go and do slight shape changes here and there, shrinking it in as we go. So you can see where it's already started to form a tuck. That's because there's too much material on this outside edge to come into the proper shape. So I'm going to take it over, do a little bit of shrinking to help pick it up, and then we'll come back over and finish tipping. As you can see, I finished the shrinking operation, so I'm going to put it back in the bead roller and tip it up just a little bit more until we get close to where we want to be, where I reach the limit of the ability to tip. I'm going to do a little bit more shrinking onto it to pull it in, and then I could probably use the hammer and dolly and just finish it back. As you can see, I got to address a little bit of distortion that I was getting. So here our corner is. It needs a little bit of something, but other than that, the shape is very close. It's hard to see that little bit of angle change, but it does have an angle change that brings it out nice and square. So we'll just adjust it very slightly for shape, stud weld it, and move on to the next part. Here we have the deck of the Wickerbill. And what I did is I laid out a center line and I laid out a horizontal line for the depth that we wanted. I then took the sweeps on the horizontal plane and figured out what radius I needed here. Then we cut it down to an even margin. That way everything that we do is nice and even, all the stretch and everything that it needs. Now we tipped it using a skateboard wheel and a tipping die. And now what we have is we have a concave panel. So if we look at it from straight up and down and we compare our two circumferences, this would be, the red line would be where we tipped. The blue line would be the cut edge. And as you can see, that radius is smaller, so we need to stretch in order to bring the panel back to flat. Because right now, this panel is not flat. There's almost 1/4 of an inch, and I'm touching on both sides. So with that little bit of stretch, you can see the tool marks. We are very, very close. I just had to put a little bit of pressure onto it, but we are really, really close. So I'm going to continue on. The panel can now be refinished. Get rid of these tooling marks and start to give it a nice satin finish. Oh, the template matches up very nicely as well. So now we have a relatively flat panel, and it's really close to being right as far as the angle and the profile go. So we'll start to get it cleaned up before we work with this anymore, and this will allow us to get some of the other parts sorted out. So with that in place and that edge tipped, we can now come in and simulate, hold it level and simulate the lengths that we need off of here to there and everything, and we can start to lay out the struts. We're going to do more of an aircraft style strut, but that's the distance off of the end of the deck lid, and everything can be figured out now. So it's a little too bright to use a laser right now, so I'm going to jump back on the things that I can do without the laser, and I'll hit it back up this evening when the sun goes down. That way I get a good bright crisp laser line. Here you can see I've used some masking tape, and I've just laid out a rough idea for what I think would be a really rad side profile for this. And we'll taper off up into that body line, come down right along into here, then taper down, die off, and we'll have a really cool strut coming up off of it. I think that's going to give it a really nice sharp look. I've measured off of here and came down where it was perpendicular and got a distance measurement, and now I can start to rough these pieces in and get all the mounts figured out, and we'll probably bring the deck right along into here, but I kind of need to get this corner sorted out, that way I know how the transition works. But that's where I'm at right now. Here are the side brackets. They're just simple bent up pieces of 19 gauge with the corner welded and then a stud welded on. Here's one of the studs here, and these are just little studs that I TIG welded on just to be extra secure. So we're going to continue to get all of these shaped into where the horizontal is correct with the laser level as soon as the sun goes down, and then we'll start trimming the tops of them and getting the side plates put on. On the sides here, these aluminum pieces will get shaped and then riveted to the small steel pieces, and it'll be just as good as welding, and that'll be the foundation for the side piece that's going to come up along the side and give us that sweeped look. Might be a little bit hard to see, but our laser line is running right down the edge of that strut, and it's running right down the edge of that strut. So we are nice and level. You can see it right there on the end of the piece of sheet metal. It needs a little bit of squaring up, but we can do that. I need to make this little cushion pocket. I have a cushion that needs to go onto a part, and then this will trap it and prevent it from being able to come out. And it's a good example, this burr is a good example of corner shrinking. So we're going to make this part. Here's our blank, and I've already done 2 operations to it. The first thing that I did is I laid out 1/4 of an inch, and I ran it through a tipping die and a skateboard wheel, and got that little bit of beginning tip done to it. Then I put it into the brake and bent the 90 degrees. So with this blank now, what we're going to do is we're going to start using hammering techniques to start bending this flange over and forming a tuck in the corner, and then use tuck shrinking in order to shrink this corner and have a one piece all the way around. There's a lot of uses for this, and you can actually do it on taller flanges and stuff like that, but it's a good way to do it. I'm only going to use 1 hammer. First thing I'm going to do is line up on the long edge, and I'm just going to set and feel it onto my dolly when the dolly is nice and into that corner. So now I'm doing the same thing with this leading edge. You can see I've gotten all that material now pushed up into that corner. Right there is when it's starting to shrink. Okay, it has a tuck formed now. The tuck is right into here. What we're going to do is just start maneuvering that tuck around. Let's see how it's kind of forming another tuck. What we're going to do is we're just going to continue to work it back into itself. You can hear that ring. There we go. So now I have to back off a little bit so I can have room to hammer, and we can get that last little bit of the corner. Alright, so you can hear the nice ring to it, and you can see how that metal has kind of grown out on that spot. But it was all just hammer shrinking that in onto itself. So now what I'm going to do is I'm just going to go over this top a little bit and crisp it up, and then we could start hitting it with a file and cleaning up our hammer marks out of there. I got a good ring.
Good ring.
So I'm going to take my shears and I'm going to cut this little corner out of it. I have plenty of material, so I don't really need to mark it right now, but I'm just going to cut that out. And that was just that excess that we had from the shrinking operation. It's much more dramatic on a bigger flange, but this is just a nice example of where that could come in handy. So as you can see, hopefully, there's a little bit of waviness in there from where we did our hammering. And what we're going to do is we're just going to take our Dreadnought file or Vixen file. We're just going to come in here. Now this is going to show us our highs and lows. We could do a little bit more hammering in order to clean it up, but this material is so thick. It's 16 gauge, and the hammer marks are so small that we could just file it until it looks good. Now the next step that I would do is I would mark and trim all of that. But what I'm going to do real quick is I'm going to hit it with a sander just like I would, clean it up, and you'll see how those hammer marks will disappear. If you can see, but it has a nice nice look to it now. So we can take it, set it up. We only need about a 1/16 for the burr in order to capture that cushion. We can take our shears and trim it right away. Once again, every time we open the shears, we move them forward. The lower anvil stays in contact with the material, and always keep it in the cut. Now by doing that, I've created a thorn-free edge. I'm not afraid to take my finger and rub all across it because there's no thorns because I used a proper technique. Now we can just take our file and we're just going to straighten out the, if I got any little highs and lows in it from shearing it, and just give it a nice presentable look using the file. Once it's filed, hit it with the sander and deburr it. Once we've deburred it, this part will be finished. So here's one of the strut assemblies. This is the steel part we welded the stud into. And now we've made a simple gusset. And then under that gusset, I put a burr around a piece of sheet metal to create a cup for a neoprene gasket. Now that neoprene cushion will take the energy that's put into it and transfer it into the deck lid without, it'll just give it a little cushion to help prevent rattling too. But when we're done, this thing will look like it has no hardware, just the hardware that's through these studs throughout the top is going to hold it. And should look pretty rad. So once we had our two outside assemblies sorted out, we come in and start fitting in the centers. Now, the very center of this one gets a third brake light. And what I've done is I tipped an edge all the way around the inside for the light to fit into. Then I put it in the brake and I bent my 3 flanges. Now, it did distort my internal flange, so I had to do a little hammer and dolly. So this is going to take a little bit more metal finishing to clean up, but it's not bad looking. But a little bit more metal finishing and a little bit of cleanup with a file and it should work good. And our light drops right in. When I did the shrinking on the side to create the curve, it actually bowed the panel a little bit, which was perfect for the bottom side of that light. Has a little bit of curve to it. So it worked out great. I shrank some curve into it to match the profile here. So what this will do is the upper flanges will sit together and it will bend right around with it. And this will become the gusset for, I'm going to have 2 center struts. I changed my mind on how to do this so that I could add that third brake light. It'll also get a rubber cushion behind it, and that'll give everything a rubber cushion and hidden hardware. So tomorrow night I will start assembling all of that and get that going on. And then once we have all of this assembled and gusseted, I will set the deck, start riveting, and then build the sides. Because then we'll know our elevation definitely, and we'll be able to come in here and build this side rather quickly. So we had our dry assemblies, and then we need to put some dimples and some lightning holes and stuff in different places. Now, in order to kind of make them look consistent, we put a self-imposed rule. They couldn't have anything within 5/8 of the edge of a panel, a flange, or another part. and I use my circle templates, I would find whatever matched the outside of the dimples. So in this case, 1 7/16. And I would lay out all of my borders, and I would come in here and just find where it needed to be to follow that 5/8 rule. If I had enough room, I would do the same thing with a smaller dimple, and I would add it if it was possible. And that kept that consistent bordering consistently away from other objects, allowed the parts to look consistent, even though they had different shapes and different sized dimples. Another thing we did is we made all the parts, so you can see that additional piece on the inside of there that holds the light for the third brake light, and we welded in some nuts so that we could have hardware to pull that out, and we added tabs to hold the third brake light, and that assembly is done. We're going to give these parts an aircraft look, and part of that is using rivets, solid rivets like aircraft used. There are different heads and different diameters. That's a dome head. This one here is countersink. The countersink, we're using all of those within the airstream or within two panels, like where the edge of the deck lid meets the side of the car. They will be flush with countersunk rivets. The length of the rivet head is very important. We can use shears. This is a riveting shear. We can use it to cut the length down. This length rivet here, I ordered them. These are measured out to be just right for a 2-panel thickness. This one here is perfect for a 3-panel thickness, and we can adjust it. These countersunks, we can shear them down depending on the different panel thicknesses. We're holding everything together with temporary rivets or clecos, and they come in different sizes for diameters, different lengths. There's one of the tools for a cleco. We have different ways of setting the rivets. We got squeezers. The squeezers have different heads depending on what you're doing. We also have the riveting gun. Now, this is different than a regular air hammer. I use mine with a regulator so I can regulate how hard it hits, but they come in different strengths, like a 1x, 2x, 3x, 4x, for how hard it strikes the rivet and how fast it sets it. Along with them, we have bucking bars, and you want a whole bunch of different bucking bars because you never know. You got that odd shape you have to get in there around a corner or something like that. Just different bucking bars are good for different applications. With the riveting gun, you're going to have different heads, shorts, stubbies. This one is for doing the flush mount rivets, and it also has to where you can use it at a little bit of an angle if you need to. With the flush countersunk rivets, you also need a countersink. And this one has a micrometer stop to where I can adjust this stop to set a different depth for the countersink. And those are all just some of the tools. For doing the rivet spacing, you might need to use a fan like this to be able to lay out your rivets with a nice even spacing. There's a lot of little rules when it comes to setting the rivets and their spacing and their distance from the edge and all that stuff, but you can see that on a different video. But I just wanted to kind of give a general overview about how we're attaching these parts and joining them together. And it also allows us to join steel parts to aluminum parts, and it's just as solid as if we had welded it. Another consideration too is your order of operation. So in this case, when the deck is laid onto here, I would not be able to put the rivets down through the deck into this flange. So the first thing that I had to do was to put this gusset to the steel part. And once that's done, I can then put rivets through that side and rivets through this side. And I had to give an access hole so that after the deck is riveted down, once the deck is riveted down on here, I can then lay the deck and this side piece onto this pre-assembly. And that access hole allows me to come up with a bucking bar through and set the rivets through the side here. And then I can set the rivets in the very front side because I have access to both sides there. But it's all just different things to consider when you're going to aircraft rivet something together. you need to be able to access in order to buck the rivets, the right diameter rivets. There's a lot to it, but it can make some really cool parts and really strong parts. So I got everything riveted together, but a few parts I forgot to video. This edge where it drops down to go over top of where the trim is for the glass, I made this little tool. Each one of these holes is 1/4 of an inch apart. And the very first hole is right at the edge of this piece of aluminum. So what I could do is I could slide it along that piece of trim right up against here, and I could mark out where it needed to be tipped, and then I could mark out the cut line, which would be 1/4 or 1/2 or 3/4 back wherever I needed it. We also added some dimples. Now, in order to make the dimples look consistent and more right, I used a 5/8 rule. So they have to be 5/8 from the edge, 5/8 from any parts, and then 5/8 from each other. And if I couldn't fit one, I just didn't use it. So everything has been dimpled and begin to assemble. The other important thing is when you're doing a solid rivet construction like this is to think about access and the order of operations. So this panel here had to be riveted to the deck first before this panel could be put on. And the reason is because you would not be able to access some of these upper rivets. So what I had to do is I had to put a beveled slot in there so that I'd be able to access it and get my rivet. In this case, I could use a rivet squeezer by simply putting it in, twisting it, and gaining access to all of these rivets. So my order of operations was very important. So now that that's happening, what I can do is I can come in, I can file, and I'm just going to take a rubber hammer and just ease this edge down to fill this little bit of gap. Then file it, sand it, and finish it. And everything's going to get burnished and a nice grain finish. So I added a corner reinforcement onto the inside, and then I set all of the thread certs for the actual Wickerbill. Made this dimple die a while back, and that's what sets them in flush like that. Last time I showed that dimple die, I had a lot of people saying, why don't you use pin nuts? Why don't you use countersunk thread certs? The material's too thin for countersunk thread certs, and most of my customers aren't going to have countersunk thread certs, but they may carry, they may have these regular nut certs or thread certs. So by countersinking them, I can use those, and then if they have to repair it in the field, they can repair it with something they already have. So, but that's all done. I still got to do some refinishing, but I'm going to put it on and move on to the sides. We've applied our weather strips and our little cushions inside of the cushion cups. Just little cups that we tipped a burr on, and they get riveted alongside the supports. The hardware, you can see the access for those rivets that I was talking about earlier. There's the mount for the third brake light, and it's ready to go back on the car so I can start sorting out the sides. But I figured I'd just give you a shot of the underside. Here you can see the small steel tabs that have the studs welded to it with the aluminum outers. And I have the laser set up so that I can shoot for the center line and set those clecos to get the part stabilized, and then I can start finishing the shape and getting it right for the back section back here. And it'll also allow me to trim that up so that there's no real pressure against the car. On this side, what I did is I took the laser and I came off of this ledge and our line that we set, and I made these two brackets based off that. And then what I did is I took this piece of extrusion that I know is straight, and I clamped it on. And once it was clamped on, then I could get all the dimensions to lay out this bracket. So once I had that, I made that bracket, and I made the one for the other side. I then roughed in my aluminum pieces, and now I can go to the other side, set my first one, use measurements to set this one. I can clamp the extrusion back on. I can set this one, and I can make the rearmost one now. It's just a process of elimination. But that's how our brackets are going to get set up. And that's going to hold everything. And like I said, it gets one more back here that I'm getting ready to lay out in a few minutes. You can see now how I'm using the extrusion to maintain a straight line and a straight elevation where I need it to be. So I set this piece flush with the inside. It is now square with all the rest of my parts. I can clamp it and then rivet it all together, and that'll be good to go. And now out here I can do the same thing. I can set my mount in here and then take my aluminum piece. I'll close the deck lid so I know the elevation of the wing, and I can get all of that figured out. And once that's figured out, I can start forming the side of the part, the side of the Wickerbill. And that will tie in. It'll use all the factory moldings and tie this thing in. Should give it a really good look. Once again, we fixtured the side up, and this time we have clamped our brace to our piece of steel. When you're using the straight edge off the deck and a shim panel to where it just sits inside of there, and that'll give us the proper elevation so that we can fit our deck and both pieces will remain flush. Just like that. Now that it's clamped, we'll go in, we'll get some rivets and some clecos into that part, and we'll move to the other side. The other thing that I did also was when I bent this back flange, I left enough space so that our side support can sit right here and take care of this blank space that would be inside, and it'll help stiffen and support this edge. But I bent that so that there was enough room for a material thickness right inside of there. So to contour the side end, we started out by making a paper pattern of what it was supposed to look like, and then slowly work that pattern in, trimming it as we went until we could set the laser up and set a point where we needed a cleco in the center of these supports. Just drilling through the aluminum first. Then just drilling through the piece first. Then pushing it in and making sure it was all the way setting against the support before we drilled the support. And just working it a little bit at a time until we had a nice reveal. So now I'm working on the other side, and I'm getting this part in because it would look weird if I went straight from down here and just cut around it. So what we're going to do is we're going to blend it in and blend it into where this piece is beveled, and it'll have a better look. Here we are mocked up on the car, and if you look down it, you know, we're straight this way. But the problem is that we are not square to that edge. This needs to come out just a little bit. It might not make a big difference, but I think it's going to look better if this is square like it's supposed to be. So what we're going to do is I'm going to remove one side, and I'm going to measure off of the edge we know is square back to here, and then we'll stretch somewhere right around in here. We'll stretch it around and get it to become square, and that'll be just one of those little details that'll look really good. So if we take a measuring tape right now, we have 58 and right around 5/8, and if we come to the back, we're at 57.5. So you can see that we need to widen out a pretty good amount to make it look right. So what we'll do is we'll mark where that inner support is here, and we'll put a stretch here, and it'll be a linear stretch. There'll be slightly more stretch, and we're going to V it in, and that'll relax this around. Here we are at the pull max. I'm going to use the pull max for this stretch, and you can see this is the die that I'm using. They make these same dies for planishing hammers and stuff like that, but what it does is when this comes down, it's going to send material to the left and to the right, and that's a linear stretch because it's in a line, but that's what I'm going to use to do that operation. Another way that stretch could be done is with either of these type of hammers against a dolly or what have you, because when you strike, it's trying to send material this way or this way. Same thing here, this way or this way. Like when you strike with the round face of a hammer, it's going to go out in all directions from that round surface. But when you use something that's linear like that, you're going to get linear stretch. Okay, you can kind of see it right there, but you can really see it with the straight edge. And that little V right there inside those marks is where I stretched it. So now I got to do a little bit of metal finishing and clean that up. But now we're right where we need to be. I can take the tape measure. .55 and right around 5/16. 55 and right at 5/16. So now I can take and trim the inside edge of this and start to set the gap that needs to be, and that'll allow me to line up my internal panel as well. And I can take this panel off and do the same thing to the other side.
Nissan's 2024 Pathfinder lives up to its name. Whatever path you choose, from muddy jungles to snowy trails to rolling sand dunes, the 2024 Nissan Pathfinder has the capability to get you there. With 7 drive modes, Pathfinder's available intelligent four-wheel drive is built for even the most epic journeys. Find your path with Nissan's 2024 Pathfinder. Head to nissanusa.com for more details. Intelligent four-wheel drive cannot prevent collisions or provide enhanced traction in all conditions. Always monitor traffic and weather conditions.
Hey, I'm Ronnie Dunn. And we're Britt and Dunn. Hey, everybody, it's Dan and Shay.
So this is the passenger side from where we did all the shrinking to get it to curve back into the body. And here's the driver's side. So what we're going to do is we're just going to take a dreadnought file or a Vixen file and start cleaning it up. Now if we have any lows or highs, we could use a little bit of hammer and dolly work. But we're going to get all that metal finish down until it has a nice clean look to it. And that'll be our next step. You can see here after the first pass of the dreadnought file that I'm flush here. I'm flush on the outside, but all of these spots are a little bit low. There's plenty of material because as we shrank, it's made this material thicker. So we're just going to do a little bit of hammer work to bring those lows up, and then we'll get to filing again. So there we are. That's about 5 minutes for the hammer and dolly and Vixen file work. And you can still see on the inside it still has all of our markings and tool markings. But now we can start taking and sanding. Start with 80 and then to 180, then to 200 grit, and we'll get it polished out. The last thing was to design the very outer spill plates. We decided to engrave some. Here the engraver is working out the letters and the turbocharger. We've refinished everything, got it all finished riveted before we added the side plates, and we tried a couple of different cuts.
The infill looks a little different, but
nothing is that really new.
Just figure that out.
So
That's a test piece anyway.
we continued on until we had our final assembly. Here the car is out in the sun. You can see just how it looks. I really think it fits the profile of the car. It's got the engraving in it. Now he's going to do a color fill on that engraving. The wicker's set up at 3/8 right now, but it has a little bit of adjustment, and then I left the bottom side long so that he could cut it down. But you can see how we matched against the back glass. All of our little struts and everything that we cut in. Third brake light. There we are. Under pressure.